All right, we're going to finish 6.2 today. We have just a tiny little bit left. And we were talking about last time, let's see, where were we? We were looking at the methods of mixed numbers. That was the last thing that we did, different ways of adding and subtracting mixed numbers. There's one other item that we're going to take a look at, and that's in this particular section. That's the idea of comparing fractions and estimating with them as well. So the first one is this idea of less than or greater than. And you've seen this definition before. And if you had a number, for instance, if 5 is less than 7, it means that 7 minus 5 is more than 0. So that's all that's saying, but it's doing it with a rational number form, this fractional form. And then also if you have this sort of notation of less than, there's an equal notation of greater than. So if 5 is less than 7, it means 7 is greater than 5. And so we can write our notation in either direction. We don't necessarily always have to put the smaller one on the left and the bigger one on the right. We can just change the symbol that we're using between them. Convenient fractions is a really neat idea. So the idea of using convenient fractions is something that you probably do, but you probably don't do it with fractions. When you go to the grocery store, you want to make sure that when you get to the register, if you're paying with cash, that you've got enough with you. Because you do this sort of a rounding off thing. And that's kind of the idea of convenient fractions as well. So when you're taking a look at convenient fractions, we're going to take a look at a couple. The first one is the number 12 over 82. So the basic idea is that we can round the 12 and we can round the 82 to numbers that are close to them, but that will basically make that fraction reduced to a nicer looking fraction. So if I were looking at this one, what could we round the 12 and the 82, each of them to make that work? 10 and 80 would be nice, wouldn't it? Because 10 and 80 would then reduce to 1/8. And I like 1/8, and that makes a lot more sense in my head when I see it. I sort of have an idea of what 1/8 looks like. When I see 12 over 82, I have a really hard time picturing what that looks like. So this is a convenient fraction. Now one of the questions, or the end of this question it asks is your estimate high or low? All right, so I'm not going to be real specific on how you have to do this. You're welcome to grab a calculator and simply look at their decimal representations. We'll do decimals in the next chapter. But you could look at their decimal representations to see if that's the case, which one's high or low. This one's actually a low estimate. It's slightly smaller than the original one. Now, I'm not going to argue too much with that one. The next one I can argue very quickly and very easily how I can determine that. So let me take a look again at the second one, part B. 2 over 1001. I actually don't really need to change the number 2. What can I change the number 1001 to be a little bit nicer? 1,000. And 2 over 1,000 reduces to what? 1 over 500, right. And the question of whether this is a low estimate or a high estimate, I can readily answer because I only manipulated one number, the bottom number. And I made that number slightly smaller. That is, the denominator was slightly smaller than it originally was. Well, the denominator gets smaller, then the fraction gets bigger. So what that means is that my fraction at the end is slightly larger than the original one I was talking about. So this is actually a high estimate. Now that's a little bit harder to argue with the first one, which is why I did not argue with it. Because I manipulated the top and the bottom, right? Now, it's not too bad, right, if I just manipulated the top. Well, if I make the top smaller, then the fraction should be getting smaller, right? Or if I have 3 cookies and I divide it by 4 people, or if I have 7 cookies and I divide it by 4 people, right? The top is bigger, then the whole value is larger. So this one right here, the top got smaller, so the whole fraction should have gotten smaller. What happened at the bottom? It got smaller, just like it did on part B. And when the fraction's denominator gets smaller, the fraction should be getting bigger. Do you see the problem here? In one of the cases, I changed it so that the fraction got smaller, the numerator. And in the denominator, I changed it so the fraction should have gotten larger. So which one affected it more? It's a little bit more difficult to pinpoint. When you just affect one of the top or the bottom individually, it's a lot easier to make that consideration. So if you see it readily, you can write it down. That's fine. If you want to verify with a calculator, I'll have a problem with that. You can do that too. All right, we're going to do one other interesting kind of problem, and you're going to have examples of this as well. So you're going to write a story problem for 5 1/4 minus 2 1/3. And it needs to be a realistic kind of example. So when you encounter problems like these, and you'll encounter them throughout our textbook, what you want to be thinking in this problem is, I'm in a middle school classroom, I'm teaching 4 and realize you're really not there, you're going to do this. You're going to say, okay, I'm supposed to be teaching about mixed numbers, and I want to create a problem that forces them to subtract mixed numbers. Hence, this is kind of a problem. So you want to think about some kind of a context situation where they would need to subtract these numbers, right? So I'll give you an example. Whenever I see fractions like 1/4 and 1/3, I think about measuring cups. Okay? Because there's measuring cups that are 1/4 or 1/3 measuring cups. You can also think about, for instance, maybe running distances or driving distances, stuff like that. So I'm going to do a measuring cup example. It's not maybe the best example ever, but I'm going to give you kind of a flavor of how you could do this. So I could say something like this. A recipe calls for 5 1/4 cup flour. I only have 2 1/3 cups in my kitchen. How much would I still need? That'd do it, right? So the nice thing on this problem, it didn't say you had to solve it, did it? It just said to create one. So once you've created a realistic problem, you're done. Does that make sense? So we can all do that, right? So there are things that wouldn't make sense on this, right? You can't do just anything with those particular numbers. It won't make sense in every situation to subtract 5 1/4 and 2 1/3. So you have to make it sort of a realistic approximation of what the numbers will be. All right, so that is the end of this section. Before we get done today, we will have time for group work, and we'll do these 3 particular